Very good evening, everyone. Can you guys hear me? Let me know in the chat, guys. Can you guys hear and see me? Very good evening, Joseph. Thank you, Arat, for confirming how you guys are doing. I have seen like some of the posts which you guys have done on LinkedIn about your code. I didn't get chance till now to look into the code, but I will definitely check those. But whoever has done the change, whoever has done the like min heap, max heap, and also some of the assignment questions, whoever has done it, I will definitely check those questions. I think Arad, you have also done it, so definitely I will check them, and I will request to everyone, please go and post whatever you are doing in min and max heap or the other one there, so other can also look into this one. Okay, guys. So, so have you guys practiced the assignment questions? I think assignment question we have already discussed, but still I want to ask because the first one was easy one, right? It was asking about creating a max heap, which I already showed you when we were implementing a heap. Correct? So that was the first question is same. The second question was you need to find the kth, the largest element, right? Kth largest element from the heap. So second question was also is very easy. You need to just delete three times because see what max heap does. What are the method we have taught in the max heap? We have taught two methods. First method was insert and second method was extract max. Correct? So you just need to call extract max three times. So when you will, so what happened when you call extract max first time? What happened when you call extract max first time? Everyone tell in the chat. What happened when you call extract max first time? Everyone write in the chat. What happened when we call extract max in heap? It takes out the max element from heap. Anyone else has any other answer? Or this is the final answer? Anyone has any other answer? Please write it out. Otherwise, I will consider this as a final. And that's totally true. It takes out the max element from the heap. And our question was asking kth largest element. It means they will provide you one value, like value of k could be 3, 2, 1, any number, right? So they are asking you to give me the third maximum element. So what you need to do? So once you see, Arad, one more thing. In your answer, it's not fully complete. Your answer, Arad, is not fully complete actually because it only it does not only take out the max element. It also heapify it again and bring the max element on the top again. It brings the max element from all the list to top again. It does two things. It first take out the max element, and the second thing, it just bring the max element on the top. Am I right, guys? That's what the extract max does. Nobody is replying other than Arad. What happened, guys? So Vishal is also replying. Okay. What about others? Shura, Sarad, Hariharan, Ekta, Joseph, Deepak, Deepa. You guys were in the last class, right? So we have only covered two methods, right, in our last class. And those two methods were insert and extract max. Correct? In the insert, we were simply adding the element into our heap and making that element into the top because we are trying to create a max. If we are trying to create the max heap, so always the array's first element will be the top element. If we are trying to create the min heap, the array top element, array the first element, top thing, array first element will always be minimum element. Correct? So then I'm saying when we are trying to do extract max or delete, so what we were trying to do there? We were trying to do two things there. First, we are trying to take out the max element. So first we have taken out the max element. Then what was the next step? We have, after taking out the max element, we were again restructuring our remaining element and bringing out the next max element into the top. Correct? That's what we are doing, right, guys? Everyone agree? So when the question was asking, find out the kth largest element, so you just need to run the extract max function that many times. So if somebody was asking, you need to find out the third largest element. So after running the extract max 2 times, you will be getting the third top in your heap. Am I right or not? After running extract max 2 times, you will definitely going to get the top element in your heap. Correct, guys? Everyone agree? So that was the question only, guys. So that's why it was very easy question, because you see the part was, so the difficult part was to implement the heap methods, which was insert and the extract max. Yes, it heapifies every time, even in insertion or even in deletion. Both times it does the heapifies. What is the heapify meaning, guys? It heapifies meaning is, in all the remaining element, bring out the top or minimum element in the first position or root position. Bring out max or min element into the top into the first position or the root position. Correct, guys? Everyone understood? Anyone has any doubt? Anyone has any doubt on that? Whatever we have covered yesterday or before that? So these were our two assignment questions. So the first question was, given an input array of unique elements, return a max heap created out of same elements. So you know that we have already created the add function. So you just need to write the add function here, which we done in the last class. That add function will just do everything. You just need to run one loop on input array, and every time you need to fetch an element from the input and add it into the max heap, and at the end return the max heap. That's what you need to do here. Correct, guys? Everyone confident about the first question? Okay, so let's see the second question also very quickly. So the second question was, which I was explaining, we have given a max heap as an input and a number k which is greater than 0 or less than total count elements in the heap, right? So k would be between 0 to the total number of elements in the heap. So we need to return kth largest element in a heap. And I told you how we will do that. We just need to delete, we just need to run extract max function of our heap 2 times. We can run, like if the k value is 3, so if we run the kth like the extract max 2 times, like k minus 1 at the heap, we are going to get the third largest element. Everyone confident about that? One show first question. This is the very simple question, and sorry for guys if you guys are hearing some background music. So you guys know that the marriage season has started. So that's why a lot of DJ and these things are happening around my area. So sorry for that, guys. So the first question was, Joseph, we have given one input array of element. We just need to create a max heap out of it. So we just need to create a max heap out of it. And we have seen it in our last class, right? That how to create a max heap out of some elements. Yeah. Oh, no, nice. Oh, very nice. I am hearing it. Not sure. It's like you can see the Mac capabilities. Might be the reliable capabilities. They are not taking some background noise. Not sure. Okay, guys. So that was the fun thing. So are we good with the assignment question? Can we move into the next part, guys? Yeah. Okay. So, guys, today, today, whatever questions we are going to see, those all are very hard questions, and those all are mostly has been asked in big companies, Amazon, Google, and whatever name you want to take it. All are very hard questions, and you will also see the applications of max heap, applications of heap as well. You will today see how much applications heap has in the real scenarios. Correct. So all those problems are going to, if you I will provide you the lead code link as well, and I will open it when we will solve the question. We'll open the lead code link also. I will show you the hard category there. Okay. So before moving that, guys, before moving into our problems, so as we know that heap can be of two types, right? Min heap and max heap. And how, what are the differentiator? If we just talk about the technical difference, if you are writing at one side max heap code, and if you're writing in the like parallel line the min heap code, so that technically what would be the difference? Technically, anyone wants to tell about what would it, whoever has implemented the min heap, they would be clearly knowing it. What are the changes they have done in their code? What was the difference? Arad, you have done it. Ekta has done it. Yes, that's the logical difference, Vishal. That the parent should be greater than his children and opposite for mean heap. Yes, that's the logical difference. Ascending and descending sort of order. Ascending and descending sort of order. Okay. Root, just order. I'm talking about the technically. I'm saying, guys, again, listen my question. I'm saying you are seeing one side the max heap code. You are seeing one side max heap code, and you are seeing another side min heap code. What would be the differences you will see in the code? You guys have done it, right? Arad and Ekta, you guys have done the min heap code. So Ekta is saying parent greater than child and parent less than child. Yes, that's what I was asking. It's just a single sign. It's just a single sign which you need to change. Correct? Just change from greater sign to smaller sign. Yes, rest is copied. That totally right. So guys, that's what I want to tell you. The difference between min heap and the max heap, it's just when you are checking the conditions. It's just when you are checking the condition. Like while insertion, if you guys remember about the code, just visualize it as I am visualizing. So while insertion, what we were doing, every time we were inserting from the backside, is inserting from the backside, and at whatever index we have inserted, we'll we'll calculate the parent index for that with the formula of math.floor I minus 1 by 2. We'll calculate the parent index. Now the difference come. If we are calculating max heap, we will be checking parent index should be greater than the current index, which we are checking. If it is a mean heap, the parent index should be lesser than the current index. That was the difference. And if if anyone anywhere condition is passing, we'll just swap it. We'll just swap it. And then again, wherever we have swapped it, we'll again check the parent index for that. And in this way, we will reach to the zeroth index, the first index. That's what we are doing in the inserts. Insert, guys. If you are able to visualize it, whatever we done in the last class, that's what we were doing. Same for the deletion. What we were doing in the deletion, just visualize it, guys. What we were doing in the deletion. So in the deletion, we were taking the top element, swapping it with the last element, swapping it with the last element, and then deleting the last element, then deleting the last element, just comparing the array. Joseph, just taking the array. So taking the first element in the deletion, always the first element would be max or min. Take the first element, and swap it with the last element in the array and delete the last element. That was the delete step, and then do the heapify. Then do the heapify. So what the heapify will do? Now the swapped element from the last has come into the first place in the array. Now we need to find out the left child. We have to find out the right child. Correct? We have to find out the left child, we have to find out the right child. And again, we need to check the conditions. The same condition. If left child is greater than the current one, so swap it for the max heap. If left child is lesser than, swap it for the min heap. That's what we were doing, guys. Correct? For the deletion one as well. So are you guys able to visualize it, both scenarios? Anywhere you guys is stuck? First let me know, because this is very important. This is very important. Anywhere you guys were facing difficulties while visualizing? The delete scenario, insert was easy, delete was also easy. So see guys, if you guys are able to visualize it, so I was trying to tell you, it's just the difference of the greater and smaller. So that's what, guys, today we are going to first create a class, generic class. We are going to create a generic class for heap. That class can be used in min heap as well, and then as well in the max heap. We will just pass something which will tell us we need to do the lesser or we need to do the greater for the parent index. So for the deletion, Joseph, if we have an array like this, 48, 32, and it would be smaller, so 31, and then for 32 it would be 28 and 26, and for 31 it would be let's consider a smaller one again, so 24 and 25. Correct? This is our array, this is the max heap. Correct, guys? Correct? That's the max heap. So for the delete, what we need to do? Delete the first element, remove this one and swap it with 25. So it will look like 25, 32, 31, 28, 26, 24. Correct? This was the first step. Delete the first element and swap it with the 25. Correct, Joseph? That was the first step. Now we need to do the heapify. Now we need to do the heapify. So go for left child and right child. Which one is greater? 32. Swap it. So it will look like this: 32, 35, 31, and like this: 28, 26, 24. Correct? This will be the step 2. Step 1. Correct? Then step 3. Again, from here. So check for the left element, check for the right element. Which one is greater? 28. So take it here. 28, 31, 25, and 26, and 24. Correct? Again check it for the 25. Check for the 25. So I think for 1 minute. Yeah, for 25, this would be the left. There will not be any right. Right? So this time it is not greater. So 25 will stay here. So this will look like after that. So the final node will look like this: 32, 28, 31, and then 25, 26, and here 24. Correct? That's what we were doing in the delete element. If we delete middle element, no need to delete middle element. We'll take from the last side. Okay, and then we will do this. Then we will do the heapify. Got it, guys? Got it, Joseph? Yeah. Okay. So now I was saying about creating a generic class. 28 left 24. 28 left is 24. You're talking about this one? The step 2, Suraj? Step 3. So how we calculate it? It's 1. So 2 multiply I plus 1. So 2, 3. 0, 1, 2, 3. So this will be the left, right? 2 multiply I plus 1. 2 multiply I plus 2. That's how we calculate the left and right. Okay. 2 multiply I plus 1. So this I is 1. So it will give us 26, sorry, 25 as a left and right. Okay. So guys, today so what I was going to tell you, we are going to create a common class with the name of heap, and in that common class we are going to pass a one function. We are going to pass one function. See guys, this would be our class heap, correct? This will be our constructor, and in this constructor we are going to pass two things. First is our data, this dot data, where we will store it in our array. And second thing, we are going to pass the comparator function, guys. We are going to pass our comparator function in our constructor. And you know, guys, what is this comparator function? This comparator function will look like this. Let me show you. In this comparator function, we will be passing two things. One is the parent index. We will write it like A1 and A2. So if we are seeing if A1 is greater than A2, if A1 is greater than A2, so like it means I am saying this A1 is my parent index, and this index is current index. So guys, if my A1 is greater than A2, what I need to do? Is it going to be max heap or min heap? If my A1 is, if I want my A1 to be greater than A2, what should be this? It should be max heap, right? If my A1 is greater than A2 and if I am returning as it as a true, it means it should be max heap. And for the in the same scenario, if I want my A2 to be max and parent index to be smaller, you can see parent index. If you write like little bit better, so why not A1, A2? Let's just write PAP. We can write it like it's JavaScript, parent index and index or current index. And then you guys can easily understand why to confuse it with A1 and A2. And then write it here, parent index and index. Now you can easily understand. When you want parent index to be smaller, that will always be min heap. And when you want your parent index to be greater, it will always be max heap. And you will be passing your comparison function like this. Now guys, with this just one function, both code will work. Like both, like with single code, you can write every like, and you can implement the min heap and max heap as well in the same code. Wherever you are comparing, you just need to use the comparator function at that place. I will show you how we have done it. Okay, and that's what our first topic is also. If you see the slide, that's the first topic for us: generic class for heap. Okay, so generic class for heap. In other language, they have done in the similar way. I'm not sure about in other language, by the way, because in Java, the heap has been implemented with the name of priority queue. Guys, just telling you, in the Java, heap has been, if you want to use a heap, min or max heap, you can initialize it with the help of priority queue. But in JavaScript, we do not have anything like that. It's missing. So you have to implement some class like that. You have to implement your own heap. Then only you can use it in JavaScript. Okay, guys. So let me show you how this looks like. And everything is same, guys. Everything. See, like they have changed the name for the method, but everything is same. I'm again telling you. I will show you quickly. I will just show you the code and I will show you. But yeah, before that, everyone understood the comparator function? We'll pass it whenever we are calling the heap function, we'll pass this comparison function, which will tell us we want to use the min heap or max heap. Hariharan, Suraj, any doubt? Joseph, Arad, any doubt? Why we are using comparison function? Anything like that? We are good, right? Okay, so let me show you the code. Okay, so yes, Let's start from here. So let me just increase a little bit size also. So yes, guys, you guys can see this is our class heap. That's how you are going to implement in JavaScript. You will be passing one comparator function, and this comparator function will only help us to identify that this particular heap is going to be a min heap or max heap. Correct? So this is the first thing, right? Then we have two main method, which is add and pull. So add is similar to the insert method, guys, similar to the insert method, and pull is similar to the extract method. Okay, pull is similar to the extract method, and add is similar to the insert method. Yeah. Yes, just to know min or max. Yes, comparator is you going to use to tell us that we are telling to the heap class, you have to insert my element in the min pattern, because see, we are going to add element in the heap. So we have to tell externally, like from the outside, that you have to use the min strategy, not the max, or you have to use the max strategy, not the min. So we are going to do that with the help of comparator function. Understood, Joseph? Why we are using comparator there? Got it? Yeah. Okay. So yeah, after that I told you add poll method and peak, like give us, you all know that peak element, give it the data 0. Correct? You all know that peak size is also, you know, that this dot data dot length. See guys, no change. I will show you now. So they have created two methods also, bottom up and top bottom. So the meaning of bottom up is nothing. The meaning of bottom up is nothing. So the meaning of, let me tell you, then I will answer your question. The meaning of bottom up and top up is, top bottom is nothing. So see guys, when we were inserting any element from, when we were inserting any element, we were doing heapify in which way? We were doing the heapify in which way? Top to bottom or bottom to top? When we were inserting, everyone just think about it. When we were inserting any element, in which pattern we were doing heapify? In which pattern we were doing the heapify? You know what is the meaning of heapify? So in which pattern we were doing the heapify? Bottom to top or top to bottom? Heapify. While we were inserting, guys, we were doing bottom to top. We were inserting from the back. And then from there we are going to the top. Oh, actually, understood. You are considering that as a top element in array. I see. Okay. I got it. Why you guys are saying top to bottom? Oh, okay. You are considering that as a top. Yes. I understood. So these are the method, guys. Top to bottom or bottom to top. Those are the methods only, which is telling you to which direction we are going there. Okay. So like you can see here, these are the two methods which we have, bottom up and top bottom. They are like in the add method, if you want to see that, we are calling the bottom up. In the add method, we are calling the bottom up. See, I understood, guys, why you guys are saying top to bottom. I understood. Because you are considering, okay, you are considering array as a stack, right? You are considering this array as a stack. So like this is 48, 45, 46, 48, just randomly entering. So if new element is coming, so it will come at the top. So you are considering it as this as a top, and then we are going into the bottom. Correct? So that's why you guys are saying top to bottom. That's why you're saying top to bottom. But that's fine. That's fine. If you are considering that as a top, then it's fine. But otherwise, if we see it in a like a stack, so it will be bottom to top, because we are considering the last element. If we are considering it in the tree, if we are considering it in the tree like this, 50, 40, 30, 70, just random tree we are creating, 30, 40, and if you want to insert any element, we'll first insert it here. Then we will start looking for the parent index. Then we look for the parent index. So that's why this flow is called bottom to top, bottom up or bottom top. So that's why we are saying this is bottom up. And when we were deleting element, we are going top down. Understood, guys? The meaning of bottom up and top down here. We are already doing it, right? When we are inserting, we are looking for the parent index, and then we are comparing it. So this is bottom up. We are going from the bottom, we are going to the parent. It means on the top. And when we are deleting from the parent, we are going into the left child, right child. So this is top down. So these are two methods written here: the bottom up and top down. Bottom up or top bottom. Top down you want to say, or top bottom, whatever you want to say. Correct. So let me show you in the ad. What we were doing in the ad, we were inserting into the back, and then we are calling the bottom up. Then we are calling the bottom up. In the bottom up, you will see that same thing is happening. Calculate the parent index, pass current index and the parent index, pass your current index or parent index to the comparator function. And based on that, if that is returning as true, swap it, and then again call the bottom up for the parent index. You know that, right? Once we switch this to the parent index, then we again check for that parent. So that's what happening here in the bottom up. See, this is a recursion call. In last class, you have done the similar thing with the while loop. Correct? If I open the max heap here, do not get confused, guys. You can do the similar thing. The insert function is also doing the same. Heap dot plus heap, first push into the heap, then run the loop when n is not equal to 0. And what is n? Which is the heap length. And again, you are finding out the parent index, then comparing it, and then swapping it, and then assigning the parent index. It means continuously that recursion call is happening. And same thing is happening here as well. Same recursion call is happening here. Are we good with the bottom? What was the name here? Bottom up. Good, right? And this bottom up will only be used in the insertion part. In the insertion part. Yeah, this is the code. The bottom up will only be used in the insertion code. Are we good? And you can see the comparator function we are using. And we will be passing this comparator function. You can see this comparator function wherever we will calling the heap class. Wherever we will calling the heap class, we will be passing the comparator function, and this comparator function will be used here. Okay. Then let me show you the top down as well. Top bottom or top down. Top down looks better, right? So yeah, in the top bottom, what we were doing, find out the left and right index, then check here. If left index only exists, then find it out for the left index. If right index also exists, find it between the left index and the right index. You can see. You guys can later check the code. It's similar code. First, we are checking with the left index. We are comparing the values, updating our next index to choose. If right also exists, comparing it with the right and the next index to choose, and then updating the next index. And if next index to choose and current index are not equal, it means there we might be getting somewhere max or minimum value. Update it, swap it. The same thing is happening here as well. In the max heap, we want to see the extract max. Same thing was happening here. First, calculate the left and right index. If left index does not exist, directly break it. If only left index exists, no right index, then go for update the left index there. First compare it, then swap it. If left and right both exist, then find out the which one is greater and check swap it. Same thing is happening with the easy code actually. See, they are also checking. First, they are checking left index exists. If left index exists, if left index is less than our array length, if it exists, check with the left index first. Check with the left index. Then update your if left index is greater. If left index is greater, update it. Then go with the right one. If right index exists, if right index exists, go for that. And then compare right index with the updated value of next. Updated value of next. So we are doing this like all three checks in these two. And then we are whatever in next index we find it out, we are swapping it. Like better code. It is written, the last code was lot of while and these come like yeah still, but yeah last code is also fine. If you do not want to use these methods, you can replace this whole class with the previous one, the code which we have written yesterday, and wherever we are comparing like these things, yeah, this thing, this dot heap, you can replace this with the comparator function wherever we are comparing. You can just replace it with the comparator function. And I will show you, I will already given you the code so you guys can convert it with the while loop also. No need to use the recursion there. So see, Ekta, we will be the one who would be passing the comparator function. We are just using the comparator function in our code. You see, in the kth smallest one, anywhere we are just using that k dot this dot comparator function. We would be the one who would be passing the comparator functions, what it has to do. But we would be passing it like a1 greater than a2. Whatever value we want to be greater first, and based on that, whatever we want to replace it. So we are not doing anything. We have not implemented anywhere comparator. We're just taking it from the outside, and then we are using that comparator function for everything here. Bottom up, top, bottom, like this. Like if you see here in the kth, when I was using one of the problem, find kth smallest, I was passing my comparator function like this, a greater than b. And I'm passing in this comparator function when I'm initializing my heap class. And now this comparator function will be used for my logic. So in this case, A would be the current element and B would be the parent index. So if the current element is greater, it means it's a max heap. It's a max heap. If the current element is not greater, what we'll do? We'll do this. Now parent element is greater, it means it's the min heap. So that's what the comparator is in our hand. Understood? Yeah, according to the requirement. That's what the see. We can only tell, right? From the outside, we can only tell this heap is going to be used min heap as a min heap or max heap. We are going to tell only, right? So this will be depending on comparator function. Whatever comparator function we will be passing, based on that, heap class will behave. Correct? Heap class is like a template, like we do for higher. Yes, for same for higher order functions also. We pass it, but yes, in higher order function also it happens. So class is a higher order functions which you can convert it in according to your requirement, and that's what happening here. We are passing the comparator function. Based on the comparator functions, we can use anything like callbacks. No, not like callbacks. Callbacks is totally different things. If you want to say that, oh yeah, the callback is not here at all. It's just function. We are passing a function as an argument in a class. It's not a, yeah, we use callback in the similar way, but the callback used basically for the asynchronous calls. Whenever we get the take the name of callback, we always say that it's a higher, like it's asynchronous call, asynchronous, because callback means later, give me result later. It's not happening anything in like that. We are passing the comparator function is in starting only, where we're initializing our class. Everyone understood? Higher order function, yes, higher order function we can say. Joseph, Arad, Hariharan, Suraj, Vishal, understood how we are passing the comparator function? You see how easily we are passing the comparator function, and then based on this comparator function, we have implemented our methods everywhere. Even see, everywhere we are using the same comparator function and passing two values. Whatever our comparator function would be, based on that, we will be getting true and false here. And if the parent index is greater, we will be swapping it. If parent index is smaller, this will giving us false. It means our current index, it's min heap. We do not need to swap it. The same way, everything is now depending on our comparator function. Are we good, guys? We have created the generic heap class, and same generic heap class, guys. Same this heap class till here to here. I'm going to use in every problems. Whatever 5 problem or 6 problem we are going to solve, we are going to see same heap class everywhere. I'm not going to touch one of the line in heap class. Not going to touch one of the class. And same heap class can be used as a priority queue. I'm not going to touch one of the line. Every time I will change my comparator function. If I want to create the min heap, I will just change the condition here. I will just change this condition. If I want to use the max, I will just change the condition. If I want to get both of the heaps, like min and max both, like this time this is max heap, right? Because A is now if I want to like in the same program, if I want to use the max or min together, so I just need to do this thing. I need to take second comparator function with the comparator 2 and change the arrow and call the heap again. Correct? With the min heap and pass the second comparator function. Now I will be using the max heap with this variable and min heap with this variable. That's what the class and the higher order functions, whatever you want to say it. Correct? Yes, heap and particle work in similar way. Particle also gives you the min element in all the elements, and same heap also does. Internally, particle implemented with the help of heaps only. Okay, guys, are we good? Any queries? Otherwise, we can jump into the first problem, which is the kth smallest element. Till now, we have solved the kth largest element. Now we are going to see the kth smallest element as well. But yeah, before that, any queries? I will like, yeah, wherever you guys stuck, let me know. So Joseph says jump, everyone says jump, we can move into the next. Okay. 4 people is saying it. What about you guys? Suraj, Hariharan? Anywhere you guys stuck? Because if you guys is stuck here, can't move it further. That's why I want everyone to, because this is not difficult. Whatever we have done in the last class, just little bit making what you know, when we start any project, we just start with anything. Just start with writing some of the requirements like that. When we have developed something, now we are just like what do you making it prettier, making it beautifully. That's what we did today. In last class, we have just understood the max heap and min heap implementation of that. Now we have combined it together, and now we can use that heap class everywhere. Yeah, with the help of comparator function, we only did that. With the one single class, we can do both things, min heap and max heap. And you can see that we can, with the same heap class, we are able to generate max heap and min heap based on these comparator functions. Are we good, guys? Yes? Everyone feeling confident? So let's move into the first question of it. Let me first remove whatever I did here. Yeah. So let me revert everything here, whatever I did. Yeah. Oh, okay. I can directly revert it from here. Okay. Yeah. So let's move into the first question of it, which is the kth smallest element in an array. So let me see if we have, I think we already have the similar problem of kth largest element, correct? So now this time we need to find a way to find out the kth smallest element, kth also, like second smallest element or third smallest element or fourth smallest element, anything they can ask it, right? So guys, tell me, okay, you guys tell me, uh, when we do the insertion of element, how we do it in the heap. You guys tell me. Okay, so I'm inserting 2. Okay, I'm inserting. Let's say let's see what example they are giving. Let's see. Take the same example. We take the same example. So we have to insert 2, then 3, then 45, 6, 79, 1, and 15. And they are giving k is equal to 2. We need to find out the second minimum smallest element in this. Correct? That's what they are asking. Okay, now you guys tell me how we do insertion. How we do insertion in a heap. So what will happen? We will first insert 2. Correct? Because there is nothing in the heap, so 2 will be the first element. We do not need to do heapify here because it's a one element only. Correct, guys? Everyone agree? Now let's insert the 3. So first 3 will go into the back. Then heapify will happen. Heapify. And then 3 will come at the first element. Guys, just visualize it in an array. Just visualize it in an array. That's what will happen. Correct, guys? That's what will happen. Okay. Now, if you want to insert the 45, so what will happen? So first 45 will be here. Then heapify will happen. 45 will come at the first position, at the parent index. So 45, 2, and 3. Am I right, guys? That's what will happen after heapify. Anyone has any doubt till now? Anyone having any doubt till now? No, right? Everyone is confident? Guys, from here, we will start our logic. So see, they were asking us, find out the kth smallest element. Kth smallest element is 2 right now. So once you have inserted in your in your heap more than kth element, start pulling out element. Once you have inserted in your heap k plus element, k plus one element, is k plus one element. Like the if they are asking 2 element, once you inserted the third element, if they are asking about the fourth smallest element, so once you have inserted the fifth element, just pull it out, just remove it. Because why we are doing that? Why we are doing it? Because we just want two smallest element in our heap. We just want two smallest element in the heap. And as you can see here, right now there are 3 elements, and always in the max heap 45 will be at the always at the first position, always will be the greater element will be there. So that's why once we have reached the condition where k plus 1 or k, once the k k is smaller than heap size. Once k is smaller than heap size, just do the polling here. Polling or extract max. Just do that. So once you do that, you will see that 2 and 3 will be here. 2 and 3 will be here. Oh, wait. No. That will not happen. No. We are forgetting the how do we do the polling. So how we do the polling? First 3 will come here. You remember, right? 45, 2 and 3 is here. If you want to do the polling here or extract max, first 3 will come here. So it will look like 3 and 2. And then 45 will be removed. Correct? Correct, guys? So we are doing k minus smallest. K is smallest. So we should take a min heap, right? We can take the min heap also, Ekta. And if you want to do with the max heap, so see, yes, with the min heap also we can do that. With the min heap, we can also do that. I am right now taking the max heap, but yes, with the min heap, we can also do that. That's totally right. That's totally right. With the min heap, we just need to delete the max heap or min heap. I think, yeah, that would be the easy actually. Yeah, I believe if you are taking the min heap, that would be more easy. Because you guys have already done the max heap one. So the min heap will also help you. Yeah, just remove the k times. Totally right. K minus 1 time, I think. Yeah, k minus 1 time. And then you will find out. Yeah, that's easy. That's easy. But yeah, just check this one also. Just look into this one as well when we are taking the max heap here. Okay. Because if you got the question that if your input is max heap, If your input is max heap array, then how to find out the minimum element? Then what you will do? You can't first convert max heap to the min heap. Correct? If that's the question, then this will help you. Okay? So let's see that. So see guys, once we reaches to the limit, once the heap size is greater than k, we will do the polling. And once we do the polling or extract max, do not get confused guys. Extract max and polling is same. So once we do that, the greater element will be removed, 45. And now after polling, it will look like this, 3, 2. Then we will insert the next element, which is 6. So insert 6. So once we will insert the 6, it will look like this, 3, 2, 6. Then we'll do the heapify, which will look like 6 will come at the top, 6, 2, and 3. Am I right, guys? It will look like this, 6, 2, and 3. Because we want only two smallest element. That's why we are doing the polling. Because we want the kth smallest element. Kth smallest element means second smallest element. So that's why in our heap, we should only have the two smallest element, not more than that. Joseph, they were asking, find out the kth smallest element. So in our heap, we should only keep two smallest element. And you can see between 6, 2, and 3, which are the two smallest element, 2 and 3. That's why we'll do the again polling. And once we do the polling, 3 will again come on the top and 2 will look like this. So that's why I have given the general condition, which was this. Once your heap size is becoming greater than k or k becomes less than heap size, just do the polling. So now 3, 2 is there. Now let's insert the next element, which is 79. So insert 79. So after inserting 79, it will look like this. 79, 2, and 3. I'm not doing heapify this time. Already done the heapify. Again, same condition. K become less than heap size. Again, go for the polling. Remove the 79. It will look like this. 3, 2. Correct? Go for insert 1. Insert 1. So after inserting 1, because 1 is already smaller, we are getting max heap. 3 will still be in the top. Again, we only have to keep two elements here. So again, do the polling. Once you do the polling, 3 will be removed from here. And it will look like, after polling, it will look like 2 and 1 only. 2 and 1 only. Correct? Guys, you guys understood how after polling 2 and 1 will remain? After polling, how 2 and 1 was only there? Why not 1, 2? You know that. Why not 1, 2? Because 2 is greater. That's why 2 will be in the first position. Why not 1, 2? You know that. Yeah. So now let's insert the last element, which is 15. Let's insert the last element. Insert 15. So it will insert it like this, 2, 1, 15. Then do the heapify. So after heapify, it will be 1, 15, 1, 2. Correct? And then do the polling, because again, size become 3. So once you will do the polling, 2 will come at the first position. At the end, guys, after inserting all the element, you got these two smallest element. You got these two smallest element. And now at the end, once your loop has been completed, you just need to print this element, array of 0. This would be the first, because this is the max heap. It means this is the greater and this is the smaller. If somebody was asking first smallest, you will be printing 1 here. But they are asking the second smallest, so you will be printing this one. So array of 0 will be your answer. And that's what similar thing is happening in code also. Very easy code. See, first, this is the same thing. We are telling we are going to create the max heap. Then it started our loop, adding it, and then checking if heap.size greater than k. If anywhere heap.size become greater than k, just poll it. And after that, return the peak element. Once the whole loop is completed, after that, return the peak element. And let me show you guys this question. in the lead code as well. I am sure this question would be in the medium, not in the easy. This question is about the kth largest, but yeah, same category. See, this question is definitely in the medium. And the same, I think, similar question we will see. There should be kth smallest as well. Find the kth largest. They are not providing the smallest, but yeah, smallest also comes. Okay. So 115, 2 comma 1, 2 comma 1. So we are only keeping k elements at the time. Yes, we are only keeping k element at the time. Then again, adding element as the entire array is not exhausted, then we return heap 0. Yes. So we are going to only keep the kth element in the stack, kth element in our heap. Once we got more than kth element, just pull it out. New heap comparator is heapifying. New heap comparator is heapifying. No, Joseph, comparator is telling us what to do here. Max or min. That is creating a heap. Yeah, that's creating a heap. You have created the class heap there. You want to initialize that class. So you can use it. You see how we use the class. This is a class heap. If I want to use this heap class, I will do new heap, right? That's how we use the classes and initialize it. So that is not doing the heapifying. Heapifying is heapifying is happening here, right? Heapifying is happening with these methods, top to bottom, bottom to top. These methods are doing heapifying, right? Correct? And compare there while doing the heapifying, they have to compare it, right? Parent index is greater or not. For that, they are using the comparator function. For that, they are using comparator function. That's why I'm again telling you, everyone, first understand this generic class which we have created for heap. Otherwise, you guys will always be confused. And this was very actually not difficult actually. This is just the class in the JavaScript. How we use the class in JavaScript. Yeah, this is the code, Arad. So we are just first we have created this line you will see everywhere in every problem you will see that because we are creating a heap here, and then after creation we are adding elements here, inserting or adding, and we are adding again and again once our heap size become greater than k, because we only want to keep kth element in our heap. So we'll simply pull it, and after that, after pulling it out, once the whole iteration is completed, we will be returning the heap dot peak. And I have showed you the example also. Do you guys want me to try then one more time? Example? Could you repeat generic class, sir? Sure. That's what actually I was saying. Please first understand this thing. So this is our generic class, Joseph, where in this generic class, we are going to use both methods here. The min heap or max heap. We can use both of the things. Correct? That's the meaning of generic here. It means because there are two type of heap, min heap and max heap. So we want to create a generic class. Generic class means one platform. So we can use both things with the one class only. So that's why we created the class heap. And how we will be deciding that I want to create a min heap or max heap, that we are doing with the help of comparator function. This comparator function which we are passing here, you can see while we are creating the max heap, this is telling us we want to create a max heap or min heap. Correct. So once we created our class, then we are using their methods: add, poll. Poll is extract max, size. You can see these are the methods classes have. See, poll method, add method, peak method, size method. We're not using top, bottom, top or bottom up because these are the internal methods. Same like swap. This is also internal methods which your add or poll are using. So that's why everywhere we will be using four methods: poll, size, add, or peak. These are the methods we are going to use it. Understood, Joseph? Now you understood? Or still has any doubt? So please explain top down ones. Top down means we are coming from the top side. It means the delete scenario. Correct, Hariran? It means the delete scenario. I already explained it, right? Did we delete scenario today? Where was that? Yeah, it's here. So see how we delete it. We start first replacing the 48 with 25, last element with the top. Then we'll go for the left and right, left side and right. You can see once we replace the 25, we are going for left and right. Whichever is greater, replace it with that. So here 32 was greater. So you can see 25 was replaced with 32. Then we are again looking for his left hand child. Which one is greater? 28. So we have replaced it with 28. Now our cursor will be here. 25 is here. Again we are looking for left and right. Right does not exist. Left exists. Left is smaller. Will not take it. We will stop it here. So this is our final array after deletion will look like. This is top bottom because from the top we are going into the bottom. This is the top bottom approach here. Understood? Where we heapify in this code? Joseph, when we do heapify, you tell me. When we do heapify, after insertion, correct? After insertion, right? After insertion or deletion, correct? After insertion or deletion, where it is happening? Inside the class, inside the heap it is happening, right? Insertion and deletion, it is happening inside the heap. So which method we are using here for insertion? Which method we are using here for insertion? Joseph, you tell me which method we are using here for insertion in the code. See, you tell me. No problem. Everyone, I know there might be confusion for everyone. So you tell me here where we are trying to insert any element in our heap. What method we are using here for inserting our element into heap? Yes, add method. And which method we are using here for deletion? Which method we are using here for deletion, Joseph? For deletion, peak is the method which gives us the peak element in the peak or the top element in the stack. Pole method, yes. So where heapify will be happening? Heapify will be happening inside the add and pole method, correct? Because these are the method which are doing the insertion and deletion. Got it? These are the two methods which will be doing the heapifying. Am I correct? Yes. So now see it. Now let me show you. In the add method, you can see we are doing the bottom up. So this is the bottom up, which is doing the heapify part. Correct? Now let me show you, let me go to the pole part. And at the end, you can see we are calling the top bottom, which is again doing the heapify. That's what I told you. These are the two methods which are doing the heapify, and those methods are happening inside the add and pole, where we are adding element, where we are deleting element. Now you got it, where heapify is happening. Yeah, that's totally fine. I hope that's clear somebody else's doubt as well. I know there might be still some doubt people have. Okay, so any other question I left? Any guys, if any question I have left, please ask your question again. Otherwise, we can jump into the next question. And all questions are very interesting today, guys. All questions. This was also interesting. Let's move into the next question. Can we move into the next question, sir? Lead code question number. Lead code question number. So, and not is this that question is not for the smallest one, 215. They are asking about the largest element, by the way. Ekta. They're not asking about the smallest one. But yeah, I just giving you the reference. I want to show you the category, medium category. You know, when you will ask these questions in the interview, if you do not know Java and if you want to implement into JavaScript, I think you have to write insertion and pole method. Sorry, add and pole method there. then only you can use the heap or priority queue. Otherwise, there is no other way to implement it in JavaScript. Yeah, in JavaScript we have priority queue, which is all. No need to implement this add poll method. Automatically, it's happening inside. You just need to import it, use it. Okay, guys, can we move into the next question now? Everyone is still have any? Suraj, Hariharan, you guys are not speaking. Are you guys comfortable here? Hariharan says yes. What about you, Suraj? Might be Suraj has bad network. So okay, let's jump into the next question, guys. Yeah, this question is also very interesting. Sort array by their frequency. So let me show you what this question is saying you. You have been given one array, guys, like this: 1, comma 2, comma 2, comma 2, 3, comma 3, comma 3, comma 3, and then you have 4. Let me see if we have any lead code example for that. 1 minute. Let me see that. Frequency. Yes, we have it. So we can read the question there as well. See, the reliable has not given properly the questions as well. That's not good, right? We can read the question here as well. See, again, the medium question, guys. So, guys, what they are saying, you have been given a string in a decreasing order based on the frequency of character, and the frequency of character is the number of time it appears in the string. Return the sort in the string if there are multiple answers, return any of them. So see, guys, what they are saying, they are saying you have been given this string TREE, correct? You need to return your output based on the frequency of the character, and again you need to return on the decreasing order. Let me show you with this array example. So you can see here 1, 2, 3, and 4. How many times 1 is coming? It is coming 1 time. How many times 2 is coming? 3 times. How many times 3 is coming? 4 times. How many times 4 is coming? 1 time. Is it correct or not? First, let me know in the chat. The frequency of numbers is correct or not? Correct. So, guys, they are asking, take their frequencies, these frequencies, take their frequencies. This is frequency. This is the element, or sort it based on the frequency. Sort it based on the frequency. Correct? Sort it based on the frequency, and you need to return it in the ascending order or in descending order. In your question here, in here, they are returning it in the ascending order. You can do it any order, ascending order or in descending order. If you want to do in the ascending order, so so first, this is the frequency, right? If you want to sort it, if you want to sort this ascending order based on the frequency, guys, based on the frequency, just sort in the ascending order. So this I will write it here, element, and I will write it frequency. You guys tell me, am I doing correct or not? So this one will come first. This is the frequency. So it means one element will come first. Then again second one will come, 4. This is the fourth element will come. Then 3 will come based on frequency, guys. You can see frequency is sorted or not. And then 4 will come. So final output will be like this: 1, 4, then 2, 3 times, and then 3, 4 times. Based on the frequency, not based on the number, guys. Again, not based on the number, based on the frequency. You can see 1, 1 frequency, not based on the number. 1, 1 is coming 1 time. 3 frequency, this is 3, 1, 1, and this is 4. That's what they're asking. Or might be in the like this decreasing order. So then it will be, output will be like this: 3, 3, 3, 2, 2, 2, then 4, 1. Any one of your can be your answer. This is they are asking. Understood, guys? Based on the frequency, not based on the number. Based on the frequency, you need to do the. Yeah, we are going to use definitely hash map because we need to calculate the frequency. Hash map or object, anything. But guys, everyone understood the questions. That's what, see, here they are doing in the decreasing order. See, E is coming two times. That's why E is coming first. And R, T, anyone can first. See, they're saying if there are multiple answers, return any of them. So like, see, R and T, they are having one frequency. So anyone you can add. So R and T, and this you can see the downside as well. C, 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 A both has three frequencies. So anyone can you can return. So you can see A triple C can also be answer, and other triple A can also be answer. Anyone you can return. Correct. So everyone understood the question now. Based on the frequency, you need to sort it out. Are we good here, guys? Anyone has any doubt? Anyone has any doubt here? Are we good, guys? No? We are good then. Correct? Arad. Okay, Arad only. What about you guys? Hariharan and Suraj, they are not answering anything. Yeah, Hariharan is there, yes. What about others? Ankit has not joined the class today. I'm just seeing 4 or 5 only people are responding. What about others? Like Deepak, Nilanjan has also joined. Nilanjan is also not answering. Suraj was answering earlier, but now he's not answering. Vishal is answering correctly every time. What happened with you guys? Suraj, Deepak, Nilanjan. Are you guys facing any internet problem? We'll use object. Definitely, we are going to use object. Yes. We can use map or object, right? Yes, we can use map or object both. Any one of them, sorry. Any one of them. Both are same. Map and object both are same. Any one of them, any one of between those two, we can use. Okay. So now, guys, let's start to solving. Once we understood the question, let's start thinking about the solution. So guys, what exactly we need to do here? So see guys, we have, definitely we have one map here, correct? Map or object, anything what you would say, correct? We have the map here. Then the next thing would be, we need to do the sorting of this map. If you just want to thinking about like simply thinking it, so next thing what we need to do, we need to do the sorting of this map. And based on, like for, see, directly we can't do any sorting in the map, right? Because we need to create against different map, and again we have to create different map and then sort it based on the frequencies values and create in the different values. Because in object we can't do the sorting, because in object you know that order, it does not matter any order, it does not keep any orders there, right? So definitely I think for finding out, it will take first, like there would be something we need to do in the map, and then based on that we need to traverse it, correct? That's what we need to do here, based on the values of keys. No, that will also not help. Based on the values of key, no. How to get element from map if key is like 1, 2? Just asking. Can't do that. We can't keep a key like that, 1, 2. So that's what I think Vishal was thinking in very nice way. If somehow, but guys, let's think in the heap way. We have heap here. Anything you can guess with the heap here, because what heap tells you, heap always gives you max value or min value, whatever you want. Every time when you will do the or delete poll or delete, hash map will always give you the greater value or the max. Like if you are taking max heap, it is going to give you the max value. Yes, Ekta has catch it correctly. We are in some way going to store these frequency in heap or in priority queue. and every time we will take always the maximum one. If somebody was asking, if somebody was asking, start from the maximum one, like see, guys, just let's think. This is the final frequency, right? No, not this. This is after sorting, right? Just remove it after sorting. So this is the frequency we have calculated, right? For everyone, every element. This is the frequency we have created, right? 1341. Correct? Yes, in 2D way. That's right. That's right. I will tell you. So this is the frequency we have. Correct? So now let's store it in. See, first we have to decide about our output. In which way we want to print our output, in the maximum order or in the minimum order. Like which element do you want to print it first, the minimum frequency or the maximum frequency? If you want to print the max frequency first, then we have to create the max heap, because all time max heap will give us the max frequency first. If you want to first print out the min heap, like min frequencies, then we need to implement the min heap here. Guys, got it? Why we are saying, why we are talking about the max heap and min heap here? If we want to first print out the frequency from the max, like the ascending, descending order, like 4321. This is descending order, 4321. So it means we need a max heap. And if we want to print a frequency in 1234 ascending order, then we need a min heap. So here we are going to take the min heap first. We are first print the smaller one, smaller frequency. Okay, so we are going to take the min heap. We are going to take the min heap. But yes, anything we can take here. Min heap. So see guys, how in the min heap we are going to keep two things. We are going to keep two things: element and their frequency. Two things together as an object, as an array or an object. Because see, you know that, right? Till now, this dot data, in this data we store our information. We store like this: 48, 46, 45, like this, right? But here we can store another array, element and frequency. Correct? Element and frequency, we can store it, right? We can store it, element and frequency. Correct? And in our comparator function, because at the end these value go for the comparison. Like if we write our comparator function, we pass a1 comma a2, and then we do return a1 greater than a2. Correct? This in the case of 48 and 46, a1 would be 48, a2 would be 46, and we will be returning 48 greater than 46. Then we'll be returning true. Correct? Then we'll be returning true. That's what was happening, right? In the comparator function. Everyone agree? But this time we have an array here. This time we have an array here. Like 1 comma, like element is 1 comma 1. So 1 comma 1. So this time in comparator function, this a1 will become an array. This a1 will become one array. Like let me write it down. So I will not replace the above one. See, comparator function is is in our hand. So we can create it as whatever you want. This is the a1, and we want to sort it based on the we want to find out the minimum element based on the frequency. So what we'll do? Return a1 greater than a2, because this is min heap. Sorry, min heap. So a1 should be less than a2. a1 a2 sorry a2 1 a1 1 a2 1, because this a1 is now an array 1 comma 1. This a2 might be 2 comma 3, 2 comma 3. So based on this value, because this is our frequency, based on this we'll decide which one is minimum, because we want to create the min heap. So based on these two values, we'll decide which one is the minimum. So let's create the min heap for this one. Let's create the min heap for this one. So now the first, in between these two, anyone can be the. So let's insert first this one, 1 comma 1. So this would be the first element, 1 comma 1. Let's write it comma, not as an arrow. You guys are able to understand, right? Comma part. Let's write it as a comma, 1 comma 1. Then 2 comma 3 will come. Then 2 comma 3 will come. Because this is the min heap, so always the first element will be in minimum. So 2 comma 3 will come here. 2 comma 3. Then 3 comma 4. So 3 comma 4. I am checking guys only the frequency. 3 comma 4. Then 4 comma 1. 4 comma 1. But you can see one frequency is greater. One frequency is greater. So this will be reaching, one frequency is smaller. So it will be reaching here. 4 comma 1. Then 1 comma 1. Then 2 comma 3. And then 3 comma 4. This would be our min heap, which will be keeping two values. And our deciding factor is second value. Our deciding factor is second value. And you can see how we are deciding with the help of our comparator function, where we are checking the second index every time. Second index, you can see we are checking every time the second index in our array. Guys, I know there would be everything little bit extra here, but totally not difficult. Yes, checking frequency values and sorting according to key. How come 4 comma 1 moved to first place? That's totally right. So what is 4 and what is 1 there, Vishal? What is 4 and what is 1 there? Vishal, tell me, what is 4 there? What is 1 there? 4 is the value and 1 is the count. 1 is the frequency. Correct? 1 is the frequency. So now you see that, and in the min heap, we always bring the smaller element on the top. Smaller element on the top. Correct? Smaller element at the parent index. Smaller element in the, so 1 comma 1 and 4 comma 1, they both have same frequency. They both have same frequency. They both have same frequency. Ah, okay, okay. I understood what you mean. Ah, okay, okay. 1 minute, 1 minute. Oh, yes, yes. He was right. What is the index of this? 0, 1, 2, 3. Let's calculate the parent here. 3 minus 1 divided by 2. Oh, yes, yes, yes. Oh, God. Sorry, sorry, guys. Got it. It will be here. It will be here actually. Okay, okay. Let's do the heapify again. I just missed it. 1 minute, guys. Let me do the heapify again. Yeah, let's do the heapify again. So the first step after 4 comma 1 will be, we will finding out the parent index. So parent index is 1. So we will first transfer it here. 1 comma 1 and 4 comma 1 and 3 comma 4 and then 2 comma 3. Correct? 1, 4 and 3. Correct? Again, now we will, now this will be our parent index. We'll again do the, again we will try to find it out. So 1 minus 1 divided by 2, which will give us 0. It will give us 0 here. But one thing is wrong here, guys. Minute. One minute, guys. I think we are printing something wrong here or what? No, no. It looks good, right? Yeah, it looks good, right? Yeah. No, no, no. Nothing got mixed up, Arad. Nothing got mixed up. We just forget the index value. So third, the parent would be 1, right? So 4 comma 1 will here. Correct? It's just that mix up part. That, like we just forget the 0th index. See, for this element, when new element is added, we just find out the we just need to find out the parent index. So parent index is 1. But what we did, we put it into the 4 comma 1, 0th index. That was wrong. That's what actually Vishal was saying. How come 4-1 moved to the first place? It has to move to the second place. Correct? Sir, one question. How did you decide between 1 comma 1 and 4 comma both have separate frequencies? Yes, we are only considering the second part. Yes, we are only considering the second pass. Everyone, any doubt? Anyone has any doubt? No, no, no. See, why does it look like wrong to you? Vishal, 1 comma 1, it is having two childs, 2 comma 3, 3 comma 4, right? 3 comma 4. And this one has 4 comma 1. Oh, one, wait. Mm, see, actually, you know why I am getting confused? Because I am every time taking the max one. Every time I'm taking the max one. That's why I am getting confused. So let's see, 1 comma 1. Then we have 4 comma 1. Then we have 3 comma 4, right? Left and right child. And then we have 2 comma 3. 2 comma 3 here, right? That's what the child is. So you can see this, because this is a duplicate scenario. So definitely in left or right, there would be one be the similar to the root one. You can see these are equal or smaller. The parent could not be greater, by the way, because this is the min heap. This is the min heap. So parent could not be the greater, because this is a duplicate element, duplicate frequency scenario. So that's why 1 comma 1 is coming here. Otherwise 4 comma 3 looks good, right? 4 is smaller than that, 3 is smaller than that. It doesn't look wrong. Yes, Vishal? It doesn't. See, I am also getting confused with the max heap. See, till now we are trying to calculate the max heap, but this is the first question where we are going with the min heap, where we are going with the min heap. So that's why actually I was also getting confused. 2 comma 3 is smaller than 4 comma 1. 2 comma 3. And see, the second part. See the second part, Hariharan. See the second part. See the second part. 3 is greater than 1. 2 comma 3 should come before 3 comma 4 in answer. 2 comma 3 should come before 3 comma 4 in answer. No. That's fine. That's fine. That's the left hand. When we'll delete it, we'll automatically do the heapify again. That's fine. See, the condition of heap is the parent should be greater or smaller than the child. That condition is matching or not. Do not see into the array. That condition is matching or not. Joseph, do not see this array part. See, the 2 comma 3 is coming is a child of 4 comma 1. It does not have any relation with 3 comma 4. It does not have any relation with 3 comma 4. Yeah. See guys, this one you guys can understand this was logical part. Let me show you the code. Code is how much easy. You see, first we have calculated the frequency. First we have calculated the frequencies here. You can see. So number I, they have passed the numbers. This is our frequency. We are passing it the frequencies here. Correct? That's how we calculate the frequency. We are not using the map here. We are using the object. We are using the object. So if number already exists in the frequency, increment it. If doesn't exist, it is coming first time, assign it with the 1. So this is the frequency part. Everyone understood the frequency part? We have seen it in the map class as well. The same thing. Everyone good? Yes. The second part is frequency. We are heapifying based on that, Hariharan. That's totally right. Correct. So now we'll look into our comparator function. This is a comparator function because we are going to heapify based on the second index, which is our frequency. So that's why I am using the one because arrays, if in array we have two elements, so 0 comma 1 index will be representing the second element. So that's why you can see in my comparator function I am saying that whenever you are doing heapify, do it based on the second index or do it based on the first index, which is the 0 comma 1, because array have two indexes. 0, 1. These are indexes. So do it based on the one index. Understood? Have you understood the comparator function now? Anyone has any doubt on the comparator function? Anyone has any doubt in the comparator function? Joseph, what about you? Again, okay, so you have also said yes. Okay, so now we have created our heap. We have created our heap. Now we are adding these keys and frequency in our heap. You can see this is the first method of heap where we are adding things. And you know that after adding, automatically at the end, we will be receiving something like this. After adding all the elements, we might be receiving like this 1, 1, 4, 1, 3, 1, 2, 3. Yeah. So let's see it. Let's see that how the heap looks like. Let me see that. If I want to print out heap, I can print out here or how? 1 minute. Am I returning anywhere the array? How does it look like? No, actually, but still we can print it, our heap. Just print it in this line. Okay. Let's see how our heap look like after adding all the elements. Okay. We will also be confirm that our heap is correct or not. Just simply print heap. So heap dot data. I think we can add the data. Yeah, we can. I think fetch the data properties. Yeah. Let's see, guys. Is there any other console? Oh, just comment it out. Just comment it out. Everything comment it out. Okay. Just yeah. Just call the frequency sort array method. Oh yeah, do not call this, do not return because result will be empty array will be returned. Yeah. So now see guys, after adding, I'm just checking how my heap data looks like. So let me see. Let's see how the array looks like. Okay. So let me run this file. So node heap class frequency.js. You see guys, 1, 1, 4, 1, 3, 1, and 2, 3. And that's what I showed you outside as well. Same thing, 1, 1, 4, 1, 3, 4. See, that's the logic, right? We have implemented the same logic. So how can it be different? Are we good, guys, with the console part of this? Yeah. Yeah. So now let's go further. Now let's remove these things. I just want to cross verify it still. Okay, so now we got this heap. Now we'll simply iterate into the heap. We'll see, guys. So now when, so first let's finish this question. Let's finish this question, then we will go for break. Yeah. So now when we have this element, we just need to poll, like take all element from here, like 1, 1. So that's what we are going to do. See, we are taking first the peak element, then polling it out. Correct. So let's draw that. Let's draw that. So our heap looks like this: 1, 1, the first element, then 4, 1, second element, then what was that? 3, 4, and then 2, 3. Correct. And this is the yeah. See it like this also: 1, 1. Otherwise, you guys will be confused. 4, 1, 3, 4, and 2, 3. Correct. So now take the peak element because this is the element which we want to print in our array. How? 1, 1. How many time it is coming? 1 time. So we'll print the 1. So that's what I am going to show you. See, first I am taking the peak element. It will give us 1, 1. Then I am polling it out. Then whatever value I got, I will be taking the frequency of it and printing value 0 that many times. So if if 3 is coming 4 times, so we will be in our array pushing 3 4 times. That's what is happening. You can see in the val1, run the loop that many times and push val 0 that many times. And while we'll do the polling, so in polling, everything will be in the right way. So once we do the polling here, so once the 1, 1 deleted, 2, 3 will come here. You know the polling, how the polling work. 2, 3 will come here. Then this will be the structure. 4, b. Again, who was forgetting the delete scenario? Again, see it. So 2, 3 is coming here. 4, 1, 3, 4. We need to check the second element, this one. So now check with the left and check with the right. Which one is smaller? Which one is smaller? This one, replace it. So 4 comma 1 will come first, then 2 comma 3, and then 3 comma 4. Check with the left, check with the right. There is nothing. So we'll stop here. Again, same process. Pull it out and do the pull it out. Do the same thing again here and push 4 this many time in our array. You can see push value from 0 that many time in our result. That was not tough question, guys. That's why it comes into the medium one. So they see what we did. First, we calculated the frequency of each element. The second step, we added them into our min heap. We added them into our min heap. After that, once we added them in the min heap, always the lesser frequency will be in the top. So first we'll take that one out. Whatever the frequency of that element is, we will push it into our result array because that many times we have to push that element in the stack in our array. Then take the next minimum element, do the same thing, take the next minimum element, pull it out from there, and then insert into the array that whatever the frequency of that element is, that's what we are doing. See, while we are hearing it, it is looking very easy. Correct? It is looking very easy. Yes, extract minimum. Extract the minimum here. Poll means extract minimum. With the poll method, we are doing the extract min here because we have created the minimum here, min heap. So in min heap, we will extract the minimum. Correct, guys? Does it look difficult to you guys? This question? It was nice. Yeah, like see, all the remaining questions are very nice questions. All the remaining questions are very nice questions actually. Okay, so let's go for break, guys. Yeah, same pattern we are going to see it. Some little bit different changes in the logic. We are going to create min heap, max heap. We are going to change the comparator function somewhere. So I think a lot of same questions. Okay, let's go for break. Right now it's 9:30 because these questions are interesting. So I'm saying you guys can come back a little bit early. So let's come back at 9:50. Okay, let's come back at 9:50 and then see the remaining questions as well. Hello guys, is everyone back? Let me turn on my charger as well. Guys, are you back? So Vishal is back. What about others? Arad is back. What about Joseph, Hariharan, Ekta? You guys are also back. Am I missing anyone? Vishal has already said it. So you only, I'm seeing 20 people has joined, only 6 people are responding. Do you guys, other people are facing any internet problem or what? You guys are facing some other problem which you can't tell here. Yeah, I'm not sure what type of magic is this. Okay, so let's jump into the next question. Next interesting question. Okay. Okay, so next question is guys, combined K sorted string or arrays string anything. So right, the question is guys, we will be giving or see there is one more question in the link in the lead code as well, which is similar question. Let me show you that also. Yeah. So they have given in the linked list, the same question with the linked list pattern. The reason for showing you this, just to show you the complexity of this question. You can see hard. This question comes into the hard category. Correct? So now let me explain you what is the question here. Okay, guys? So you can see this input. Yeah. So you have been given one 2D array or matrix. You can consider like this. This is the 2D array we are going to create. And in this 2D array, you have a sorted array. You see, you have this sorted array 1, 3, 5, 7, 1, 3, 5, 7, and then you have 2, 4, 6, 8, 2, 4, 6, 8, and then you have 0, 9, 10, 11. 0, 9, 10, 11. You can consider them as a linked list as well, like three different linked lists are there, sorted linked list. And then at the end, guys, you need to return your answer as a merge list with the sorted element, so like 0, 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, comma 8, comma 9, comma 10, comma 11. This is what you need to return at the end. So you have three sorted linked list or simple list. Let's take array. So you first in the question you have been given one 2D array, and in this 2D array, inside the array you have a three different rows which has sorted list. Sorted list. You need to combine them and return the final output here. Did you guys understood the question? This question is known as merge sorted array. Everyone understood the question? I would create a BST and written in order. Yes, BST and written in order. So for creating BST, you still need to merge all the arrays, right, Vishal? So merging will take time, right? See, simple would be merge all the array and sort it. That would be the simple answer, right? Merge all the array in one array and then sort it. So see, Harat, the question is, you have been given one 2D array. You can see the 2D array here. And in the 2D array, you can see they have been given three rows to you. You can see these three rows are here. And then these rows or these lists are sorted list. So you have to return one combined result where you need to first check all these lists And in this list, whatever the sorted elements are here, you need to insert it in that way, in the sorted way. Yes, Ekta has find it totally correct. Just think, because see, all other ways, whatever way you try, they will give you lot of time complexity. But with the min heap or max heap, you are going to get lesser complexity. And that's why we are going to use min heap here. But yeah, before that, everyone understood the question? Arad, you understood the question now? We have three different, we have 2D. Oh, you still didn't understand. Is it still network is problematic here? You got this 2D array. In this 2D array, you have these rows. These rows are sorted rows. You need to return, combine these rows in a sorted manner. You can see 0, 1, 2. This is the combined one. 3, 4, 5, 6, 7, 8, 9, 10, 11. So you have to combine all these rows and return the sorted answer here in the sorted way. Understood, Raj? So you have three. Yeah. So that's what the question is here also. You can see this is the list. They are telling it's a linked list. And then you need to return an output as a combined linked list here in a sorted way. 1, 1, 2, 3, 4, 4, 5, 6. And you can see, guys, this is the hard question, not the easy or medium question. Okay. But yes, with the help of min heap, we will make it easy. Let's see how. Let's see how. Okay. So what we are going to do, guys, I'm erasing this answer. You guys know that, right? This is the final answer which we need. So we are going to take min heap. Definitely we are going to take min heap. And in that min heap, we are first going to insert our first column only. We are first going to insert our first column. Okay, so let's insert our first column. So let's see. First we'll insert from this one. So first one has been inserted. I'm using the array structure. Okay, guys. So one has been inserted. This is the one. Then insert two, because it's the min heap. So who would be the first? One. So two will come here. Yeah, two will be staying here. Then zero. Then we have the zero. So zero will come here, and after heapify, this zero will be replaced with this one. Then zero will come at the first, two will come here, and one will come here. Correct? This is the first insertion, first column insertion, first column insertion. It looks good, right? It looks good. We will not traverse everything. We will not traverse. Correct. Now, guys, what we'll do, we will first pull the first element from our min heap. We'll take out the first element from here. Correct. So now let's take the first element from here. So once, let's do the polling here. Let's do the polling here. So now, after that, 0 will be going out. And after that, I think it will look like 1, comma 2. After polling, 1, comma 2. Am I right, guys? After doing the polling, we'll see the 1, comma 2. Right? Yeah. So now, whatever element we have taken it out, whatever element which we have taken it out. So this is the element which we have taken it out. I'm writing it as a peak element. 0, right? This is the peak element. So what we'll do, guys, go to this element row, and take the next index from there and insert it, add it into our map, add it into our min heap. Add it into our min heap. So now 9 will be added here, right? And 9 will be added here. So now you can see 9 will be added here. Correct? Understood? 9, and because this is 9 is the greater, so 9 will be adding here. There will not be heapify will happen on the insertion. So 9 will be stay here only because it's a min heap. So 1 will be already there. See, right? Correct? Now, guys, again do the polling. Again do the polling. So now this time peak element would be 1. Again do the polling. So after that, it will look like this: poll 2 and 9. Correct? Now what we need to do again, guys, whatever peak element, go to that row and put the next element. This is a 3. So now we'll put the 3 here. And now we'll compare it with the parent. So yes, it's still parent is smaller. So we will not touch our parent. Are we good, guys? Till now, are we good? We are going to follow the same step till the end. We are going to follow same step till the end. Okay? So we are pulling it out. Whatever the minimum element, we find it out after traversing the first column. Whatever the minimum element we find, we have to take it out. We have to sort it, right? At the end, we want our sorted answers. We want our sorted array. So whatever the minimum element is in the top, take it out. Yes, we have to, but why we need to check in whole array? See, we have a sorted arrays already. We have a sorted arrays. Correct? So always see. Okay, I think yes, Arad has asked very nice question, by the way. See, guys, I think he has asked very nice question. Why we are not checking this 0 with everything here? The reason is, see, these are sorted arrays, and always the first column will always be, because see, first we have taken first column first, and we have find it out the minimum out of that, whatever minimum is there. Then we are checking for the next, then we are adding the next element. You can see first we have inserted all these three elements all together, 1 to 0. Then we pulled it out the minimum element. Then we are taking the next index of that row only, and then whatever minimum element is coming, we are going into the next element of that. So see, after polling and inserting, it just adding a new element in the heap. And when we are doing the polling, always we are taking the minimum element in all of the elements which we have inserted into the heap. What if row is 0, 1, 10, 11? Correct. What if our row is 0, 1, 10, 11? So 0, and what is the next row? Arad, what is the next row now? What is the next row here? Is it only one row is there? If it only is the one row, so 0, first we will insert the 0 in min heap, then we will take the next element of that row, which is 1, then we again do that, take the next element of it, which is 10, then again we will take the next element of it, 11, if it's the one row. Arad, just visualize it. In the first column, we are taking the minimum element. In first column, we are taking the minimum element. After that, whatever row we are at, we just adding the next element out of it. There will not be any item which will be missed here, because we are adding every element. And because this is the sorted array, so this will not create any problem here. Okay, so now let's continue. So now right now we have added 3 here, and which is 2 is still smaller. So again we'll do the poll here. Again we'll take the peak element, which is 2, and then we'll do the poll. So once we do the poll, 2 will be deleted and 3 will come at the top. 3 will come at the top. 3 and 9. Now, once we take the peak element, take the next index from that row, which is 4. So add 4 here. Correct? Now again do the same thing, because see, this is still heapify. So again do the same thing. Now 3 will be out. In the peak, 3 will be out. And after polling, it will look like 4,9. Am I right, guys? The minimum element will be always be on the top. 4,9. Now take the next index from 3. You can see we are taking the 5. So now insert 5 here. And this is looking good. No need to heapify. Again take the poll 4. Peak as 4 and poll as here. Again 5, 9. The next element of 4, which is 6. So guys, are you seeing the flow here? We started with first column. I'm not getting on what basis we are choosing. So minimum element. whatever minimum element min heap is giving us, based on that, we shall see the last row only. See, we have picked the minimum element here, 495. So minimum element we are taking. So we are going into that row and taking the next element. Minimum element. Whatever minimum element we have min heap is giving us, just go to that row, pick the next index. Understood, Vishal? So guys, now this is the way we are going to solve this problem. This is the way we are going to solve the problem. But still two things is missing. In each step, we are polling. See, Hariharan, this question is totally irrelevant. If you have understood, if you have understood the heap class, you know that adding and polling automatically does the heapifying. Adding and polling automatically internally done the heapifying. When I was answering this to Joseph, I have showed you. So this question is totally doesn't make any sense. You are saying in each step we are polling and heapifying. Heapifying automatically will happen when we do the polling. That's the magic of, not magic. We have implemented it. Correct? Understood, Hariharan? Every time addition and polling, whenever it is happening, whenever we are calling add method on polling method, automatically internally we are doing the heapifying. Got it, Hariharan? You want me to show it? Or you understood the line which I am referring to? Got it? Yeah. So guys, in this question, we have understood how to pick element and how to insert our answer, because this is going to be our answer. All the peak element is going to be our answer, and you can understand how to what element we are picking. But now the question is how to get to know the row number and which index. How to know, if Vishal you were asking this question in your previous one, how to know which row and which, because we are in the heap map, you can see we are only inserting the elements 1 comma 2 comma 0, but how we are getting to know, this 2 or this 1 or this 0 exists in third row, because this is the third row, this is the second row, and this is the first row. But how we are getting to know that this 0 exists on the third row? Or what is the next element? Where to stop it? Correct, guys? Did you guys understood what I'm trying to say here? We do not know that thing, right? We need to see. If we do not know that, we need to go into the array and find it out. This thing, right? Every time after deleting, after polling it out, when we are polling it out or taking the peak element, like first column, after first column insertion, when we are polling it out, we need to go to the, like this is the first element we poll it out, right? 0. So we need to go into the array, 2D array, traverse it, find it out, 0 exists in which row, what is the next index. That's all we need to do. Am I right? See, you guys are able to visualize it or not? Everyone, Vishal, Joseph, Arad, Hariharan, you guys are able to visualize it? What I'm trying to say here? See, विशाल देखो क्या कर रहे हैं हम, हमने पहले अपना कॉलम के सारे एलिमेंट्स को मिन हीप में डाल दिया 0 2 1, ठीक है, गॉट इट। हमने अपने शुरुआत के तीनों एलिमेंट्स डाल दिए, करेक्ट। नाउ वी आर व्हाट वी आर डूइंग, वी आर पोलिंग इट आउट। सो वी आर पोलिंग द फर्स्ट एलिमेंट व्हिच इज 0, वी हैव पोल्ड इट आउट। नाउ व्हाट आई एम सेइंग, आई वाज सेइंग जो भी हमने एलिमेंट को पोल किया है उसकी रो पर जाओ, go to that row and take the next index, which is 9. That's why you can see 9 has been inserted here and insert it into the min heap. That's what I'm saying. Yes, but why? See, we need to traverse it, right? We have to merge all these arrays. We have to merge all these array in a sorted manner. So we have to traverse all the elements. We have to traverse all the elements. And once we have to traverse all the element, so we have to go to that row and pick the next index from there. Now I understood, but let me first I think that's a different question. First, you understood the answer of your why, Vishal? Because हमें सारे एलिमेंट को मर्ज करके एक एरे में बनाना है. So we need to pick all the elements. How to pick it? Whatever minimum element we have taken it out from the min heap. Just go to that row and pick the next index. अभी समझ में आया? The second one also. Yes. So now I was asking, there is one problem, and problem is how to know which index to pick, which index, like, I mean, in that row, which index to pick, or how to know also row, because in the min heap, we are only storing 0, only storing that element, not storing anything else. So this is difficult for us. So that's why, guys, in our min heap, we are going to store 3 things. I just showed you with this example that we are storing only one thing, but guys, we are going to store 3 things here. Now again, like the previous question, this question is also going, in the previous question, we were keeping 2 things, element and frequency. But in this question, we are going to keep 3 things. So the 3 things would be the element, row number, comma, current index. Current index or we can say the next index also. Next index. Whatever the index we need to take, the index, the next index. Did you guys get it? Why we are taking 3 values at one place? See, we were earlier taking 0 only, one value, but we were facing difficulties to find out the row number and the next index. But now, when we will be inserting, we will be already adding 3 things all together in one place. But comparison will always happen based on the element, the first value. A comparison will only happen based on the first value. Guys, I don't know, you guys like find it difficulty, but it's very logical here. Why we are taking 3 things here. And with the previous questions, I think you guys have understood now the comparator function also, how the comparator function work. In the comparator function, we are only going to check the element for our heapifying process. For our heapifying process, we are only going to take the 0th index. Anyone has any doubt here? Joseph, Ekta, Hariharan. Are we good? As we are going to take 3 elements? Yes? Very nice. So how can anyone quickly tell me what will be the comparator condition? What will be the comparator condition? Because we are going to create the min heap. First is the min heap. And we also know that the element we are going to take, an element at the 0th index. So what would be their comparator condition? Yes, yes. Totally right. Hariharan and Ekta has given correctly. A0 less than B0. Because we are going to compare the element only, not the row number, not the next index. Yes, Joseph, yours is also right. Yeah. So that's me. Let me show you this much code. Then we'll talk about the further. Guys, see, the first are comparator function. And then you can see, once we have created a heap, we are inserting only the first column. You can see I is equal to 0. And you can see only the first column. Array.length, only the first column. You can see 0, 0, 1, 0, and then 2, 0. Only the first column we are inserting, and you can see the second argument as the row number, and the third argument is the next index. So this will be inserted. Let me show you the only the one row. Then you guys can later relate it with these things. So now later related. So let me show you just one, like this one. The first insertion I will show you, then you can later relate it with this. So see, first time, the first row, 1, 0, 1. So this will be inserted like this, 3 values. 3 values will be inserted like 1. What is the row number? Row number we can consider as a 0. And what is the next index it has to take, which is the 1. So 1, 0, 1. This will be the first element will be inserted in our heap. Now the next element 2 will be inserted. So based on this, and a comparison will happen only in the 0th index. So 2 is still smaller, so 2 will be here. 2, what is the row number? It's a it's a 1. Row number is 1. Next index is again 1. This 2, 1, 1. And then the 0 will come, the last element. Now the 0 will come, 0, comma 2, comma 1. Now the last element will come. And now heapify process will happen, and this 0 will come at the first position. So this will look like this: 0, comma 2, comma 1, 0, comma 2, comma 1, then 2, 1, comma 1. Same heapify process, guys. And then last 1, comma 0, comma 1. Why I have not showed you this? This is going to take 3 values. Otherwise, if I was be telling you all these 3 things from the starting, you guys won't be able to understand this part. So now you can see after that 0, 2, 1 looks like this when we'll be having the 3 elements. And now when we will be pulling out the first element, so we would be getting 2 more values with that. Second row, first index. That's how we will be getting to know from which row, which element we need to pick. And every time, whenever the next element we will push, we will add it. Like we will update these values. We'll do like, we have to push 9, right? We have to push this 9. We have to push this 9. So what we'll do? What we'll add? We'll add 9, same row, so 2, and increase the index value, because after 9 we have to check the second index, which is 10. So that's how, guys, we are going to do that. First, let me know, did you guys understood? Any confusion here? Yes, it's totally based on the comparator logic. Yes, everyone understood how we are able to, how smartly with the help of heap function we are able to reach quickly to each row, and also the index. Makes it clear? See, guys, there will be one more condition. See, because this logic continuously will check, but once it reach to the last index, we need to stop it, right? We do not need to insert any other element. Once it reaches to 11 or 8 or 7, anywhere, we do not need to insert any element, right? Further, because there is no other element in the heap. Okay? So we will put one condition there. We will put our condition there. Then once the second element value is greater than that particular array's length, see, we will put this condition, guys. We'll put this condition when the index value, which is the third value, like see, so for consider for this. So the heap value will look like this: 7, 0th row, and index would be here, I think 0, 1, 2, 3, 3. Correct? This will be the structure for 7 when we will pull it out. 7, 0, 3. Anyone has any doubt? 7, 0, 3. 7, 0, 3 looks good. No, it won't be 4. Oh, yes. Correct. No. Vishal is right. Wait. When we will insert 7, so it would be current index plus 1. Yes, the current index plus 1. Yeah, it would be 4. Correct. Because see, when we were at the 1, we were be having, see, when we were be at the 1, we was having 1 at that place, right? Not the 0. So it means we will be having 4 here. We are keeping the next index, not the current index. I told you, right? Next index. Yes, Vishal is right. We will be having next index here. Correct? Yes, Vishal, you're right. It should be 4. 7, 0, 4. Yes. So now we need to put the condition here when the value of index, is greater or equal to array length, we just need to stop it. Or how, like which array? We can get it from here. I am talking about the zeroth row. So when the index value, when the next index value is equal to this zeroth row length, we have to stop it. We do not need to insert anything there. We don't need to insert anything there. Understood, guys? The stopping condition. Yeah. So now, if you guys have understood everything, now let me see the code. Very easy. Same thing. Whatever we talked about, we'll do the similar thing in the code. Let me show you. See, guys, comparator function, already discussed it about it, because only the zeroth element we need to compare it. Then we have our heap, which we have initialized it. Then we added our first column. You can see this is our first column. Correct? Now what we are doing? We are running second loop here. From the array dot length to the like the m cross n, like row multiplied by column. Correct? Array dot length will give total rows, and array zero dot length will give the total column. So 4, like in our case, it would be 3 multiplied by 4, 12 times. This loop will run 12 times. Okay. Now you can see same thing. Every time take the peak element, poll it. That's what I'm saying. Take the peak element, poll it, push the answer in, push the zeroth, because at the zeroth place we have the element. So push it into our result array. Then check the stopping condition, when to add, when not to add. So this is the condition when root 2, it means the last value is less than array root 1 dot length. Because you know that root 1, just visualize it with the 7 values. So 7 is here, 0 would be root 1, and root 2 would be the 4. So when 4 is less than array root 1 dot length, then insert it, otherwise do not insert it. And you can see while inserting, we are just taking that row number. You can see root 1 will give us the row number, and root 2 will give us the index. So that way we'll take the value, we'll insert the same row number, and for the index value we are adding it +1, and at the end we are returning the result. Guys, whatever we discuss, we have done the same thing here. We are taking the peak value. That peak value is containing 3 values, 0, 1, 2. We are using those 3 values here to solve our problem. Let me just wait for some minute, and so you guys can take a look into it, and then we can go into the next question. See, code is not difficult. It's just easy and interesting. All these questions are very hard and just need little bit logical. So please explain stopping condition once again. So see here, we need to stop it. We need to stop it here. Once this once the index value is greater than, once this index value equal than or greater than to the this row length. So you can see this row length is 4. This row length is 4, and index is also 4. So we need to stop it here. Or we can say whenever this index is less than row length, we can insert it. Whenever we have this index value less than row length, we can insert it. And whenever this row index become equal or greater than the row's length, do not insert it. That's what the condition is here. You can see whenever the index value is less than the current row length, insert it, add it into the heap. If not, do not do anything. Got it, Harian? That's what happened. So how was this question, guys? Did you guys see this question as interesting? Or was it difficult? Because you know the heap, so you can see how easily heap has helped you. Where, Arad, you got confused? I think I explained it nicely, right? Still, it make it confused. Still, you were confused, and at which place? Interesting and confusing. Hard question turned to simple. Yes, yes. Okay, Joseph. What about you? Any place you got stuck? So we are good. So let's move into the next question. Next question is also very interesting, guys. Let's see the next question also. That's also a hard question. To find median in real time data. Let me show you this question is hard or not. In the median in linked list, oh sorry, lead code. Find medium from real streaming data. Data is streaming. These are, you can see these are the applications of heap. These are the applications of heap as well. There are after that, I think job scheduler is also there, task scheduler. You can see find median from the data stream. This you can see again, it's a hard question, and we are going to make it simple again. This question with the help of heap. Okay, so first let's understand what is this question about. Okay, so guys, they are saying data is streaming. It means you are getting some data in some interval, right? Right now we are doing streaming. Like I said something in some interval, you will get it. Again, I will say something, you will get in some time. It means you do not have all the data at a one time. You will get data one by one. You will get data one by one. So once you are getting data, you need to tell at that time what is the median, whatever data you have, what is the median right now. So let me show you. So guys, you can understand first you got the data as 2. So what is the median right now? So guys, yeah, before that, what is the median? You know about the median? So median is, how do we calculate median? First thing, first category for median, always data should be ordered. Always data should be ordered, right? And if we have like uh, 2 4 6 comma 8, if we had 10, if we had even number, sorry, odd number, if we have an odd number, just take the middle element as your median. So median would be 6. And if you have even number 2 comma 4 comma 6 comma 8, just take these two elements and do the divide by 2. You will get median as a 5. This is your median for even, and this is your for median for odd. Did you guys remember? In the binary search question also we talked about the median, getting ideas about the median. And but yes, the median condition is always data should be ordered, because that's why we are using the median in the binary search also. Binary search is also sorted. Sorted, it means sorted, ordered. Hmm? Okay, so now we have understood. How we understood the median. So now tell me, for 2, what would be the median here? This is the real data you are getting. So at time 0, you got 2. So what would be the median here? Median would be 2 here. Correct? Let's take the input from here only, from the question. Okay, they are taking 1 first. So let's take 1, no problem. Let's take 1. I'm taking the input from there. So 1, median will be 1. Correct? Let's take the second input, which is the 2. Now tell me what would be the median. We have 2 inputs now, 1 comma 2. What would be the median here, guys? 1.5. Yes, because it's the even. 1.5. What is the next one? Next one is 5. So now we have 3 elements, 1 comma 2 comma 5. You can see they're still ordered. So now the median would be 2 here, right? Now let's insert 7. I think 7 is there, right? No, 3. Sorry, 3 is there. Now it's a 3. So now what would be the median here, guys? Now we inserted the 3 here. What would be the median here? It's not ordered. So we have to first make it ordered. So we have to make it first ordered. So you can see 1, comma 2, comma 3, comma 5. And then now we have to calculate the median. So what is the median here, guys, now? 2.5. Correct? You guys corrected, got it correctly. Not ordered, so we have to first ordered it. And then we have to calculate the median. Okay, that's why I've chosen the question, because I know that there will be ordered scenario will come. And now I think everything you know. You can insert something else, 7. So you can insert it at the back only, 3, comma 5, comma 7. And I think answer would be 3 here. Then I think the next number is 4. You can insert the 4 as well. Make it ordered first. 1, 2, 3, comma 4, comma 5, comma 7. And then take these two. So 3.5. Correct, guys? That would be our answer. That's what they are asking here, guys. That we need to print the median of real-time data. So we will pass the data, calculate the median. Pass the data, calculate the median. Pass the data, calculate the median. Understood, guys? Everyone understood the question? Yes? Let's see, Hariharan, let's see. What are we going to use? I know you guys are excited to know. Yeah, let's see. Okay. So first, before that, let's understand with this question. If we have event scenario, let's first understand again uh, our knowledge of the median. With that, we will decide what to take. 2, 4, 6, 8, comma 10. Right? So this is the odd scenario. No, let's take the even one first. Let's take the even one first. We'll go into the odd one, no problem. Let's take the even one first. 2, comma 4. Correct? This is the this is the even scenario, right? When we have even numbers. So what we do here, we just take these two elements and then do 4 plus 8 divided by 2, which will give us 6. This would be our medium, right? Correct, guys? That would be our medium. Yes. So let's think about it. If we let's draw this again. 2, comma 4, comma 8, comma 10. If we just draw a line here, so this is the half part and this is the remaining half part. This is the half part. This is the remaining half part. Let's take 2, comma 4. Correct? So this left part, left half part, which element we need to take? We need to take the max element from here. And from the right side, this is the left side and this is the right side. So from the left side, we need to take the max element. And from the right side, we need to take the min element. See guys, see if we want to use simple min heap or max heap, if we will apply in this whole array, like if we want to apply on this 4 elements, the min heap, so min heap will give 2, right? And max heap will give us 10. Right, guys? If we'll apply 2, 4, 8, 10, if we will apply min heap into that, it will give us minimum element. If we'll apply that, but we do not want that. We want middle elements. We want middle elements. So for finding a middle element, we need to divide it. We need to divide our array. So that's why you can see I divided this array. And in the remaining half, I need to find out the max one. In the remaining right side, we need to find the minimum element. Did you guys understood now why we are doing this divide part and finding out the left and the max, and on the right side we are finding out the... Understood, everyone? Yes. So answer for your question, who was asking about, who was asking that, like, are we going to using min heap or yeah, Hariharan? We are going to use both here. We are going to use min heap, max heap, both here. And you know the reason why we are going to, because with the one min heap or max heap, we are not going to get the answer. So that's why we need to divide our arrays and then pass it. Then we have to do the min and we have to use both scenarios here, min and max. So let's see what will happen in the odd scenario. What will happen in the odd scenario? So see guys, for the odd scenario, we will take some assumptions. So like 2, 4, 6, 8, 10. This is the odd scenario, right? Again, we'll do the divide, but this time in odd scenarios we will always consider or we'll always consider one scenario that odd in the odd scenarios the max or left part will always have one extra element or left side array will always be greater than the right side array, right? Like like there could be two scenarios. Left side could be equal to left array size, could be equal to right array size, which will be the even scenario, or the left side will always be greater than the right side. See, this is in these two things could be possible. We can also take like, and then we'll take the max from here, max heap from there. So will be which will give us 6. This is the one thing. We can also do the similar thing with this also. 2, 4, 6, 8, 10. We can divide it from here and then take the min element from here. Then this condition will reverse. So right array. So with this logic, right array will always be greater. So we have to decide which one we have to take. Right array will always be greater. So we are going to guys take for the odd scenario this left one. That we are going to say that left one is going to give us the max scenario in the odd scenario. Got it, guys? Both ways fine. Both ways fine. You can find it out the max from the left array, or you can go for finding out the minimum element from the right array. Anything you can do. Both ways fine. Now, guys, are we good with this assumption now? Anyone has any doubt in this assumption? For the odd scenario, we are going to take the left one. From the left side array, we are going to take the max element for our odd scenario. We'll talk about it, Vishal. We'll talk about it. But let me show you first this last part. Then we'll talk about how to insert these elements. Let me just show you the last part where we are returning the answer in the code. Okay. Let me show you the last part. Yeah, this part. Find median. Just simple this part. If the min heap size equal to max heap size, if both, because this will only happen in the even scenario when both of min heap and max will have the equal size. See what you need to do? You need to take the min heap peak, max heap peak, divide by 2. Else just return the max heap dot peak. That's what we discussed, right, guys? Odd and even scenario. Correct? Understood? That part of code. Else, yeah, else is there. When they do not have same size, it will happen in the odd scenario. 3, 2. You see this, right, Joseph? You saw this. Left array will have max heap will have more size here, right? Max heap will have more elements. So in the odd scenario, we'll take the peak from the max heap. Did you guys understood this part of code? That's what we discussed, right? Before discuss, I'm just showing you the same part. Got it, Joseph? Joseph, got it? Yeah. What about others? Everyone got it? I just want to show you this part of code because that one is easy, right? Now the difficult part is how we are going to add our number in min and max. That's the interesting thing. Add our real-time data in min and max heap. That's what we need to think. That's what the important part, because keeping data is there simple, but how to add it and manipulate it. Where to add it, what number, that what we need to decide. See, because see how the data is coming. Data is coming at the real time, right? Now let's see the data, this particular data, the 12537, this is coming in the real time. So where to insert? Which part to insert in min side, which part to insert in max side? That's what the difficult part here. So that's what we're going to do. So I'm going to create max here and min here. This is the max heap, this is the min heap. And always keep this assumption that max heap can have one extra element to compare to the min heap. Always keep this in your mind, because for the odd scenario. Are you comfortable with this assumption, guys? Why max heap will have one more extra element? Yes? Okay. Let's start inserting them. Let's start inserting them. So there just some steps are there, guys, which you need to follow every time. But let's see. Let's see. So first we'll insert the 1 in the max element. See, because this is the first element, and first element will always be the odd. The first element will always be the odd because it's odd. So always insert the first element in the max one. Min heap will be empty here. Min heap will be empty here. Correct. So in this function, it will come into this scenario because min heap size and max heap size is not equal. So it will come into the else part and it will return the max heap dot p, which will give us the one answer, one as answer. So now we are okay with, right? The first one, we got the one answer. How we got it? Are we good? Are we good? Let's think about the second one. Think about the second one, where we need to insert it. So guys, this is the 2. So guys, what we are going to do, like where we need to insert this thing. See, ideally, this 2 should be inserted on min edge here, right? This 2, this should be inserted here. Correct? Anyone has any doubt why it is has to be inserted in min heap? Because according to the median logic, you can see according to the median logic, for the event scenario, what we are saying, min heap dot size and max heap dot size should be equal, and then take the peak element from there and divide by 2. Correct? So that's why see, but do not generalize this idea. I'm just telling you, do not generalize this that every time even element will come, it will go into the min edge. No, do not generalize it. But in this scenario, it should look like this. Correct? It should look like this. So then the peak of this will give us 1.5. Are we good? 1.5. Correct? Now let's talk about the 5. Now let's talk about the 5. Where we need to insert it. See, 1, 2, 5. If I see here 1, 2, 5, if this is our array, if we divide it, so you can see 1, 2 should be on the left heap and 5 should be on the right side. Correct? 1, 2 should be in the left heap and 5 should be on the right side. Is it correct or not? Correct, guys? This should be the correct. That's what we are saying. Max left side, max heap should always have one extra element. So just think about how can we move this element here. We have to do in the similar way. We have to move this element here. So we need to somehow for 5 move this min h pop, like we have to pull it from here and put it here like as the top element and 2, 1 and 5 here. How we'll do that, I will tell you. How we will do that, I will tell you. But this should happen after 2, 1, 5. And then your median function will again see that min heap size and max heap size is not correct. Print the max heap peak. And max heap peak is 2 right now. That's why your answer is 2. Correct or not? Correct or not? That's how we'll do that, I will tell you. But that's how our max heap and min heap should look like. Correct? Everyone agree? I will tell you how to do that, but that's how they look like. Okay. Let's insert three also. So let's see. Let's take four elements now. One comma two comma five. Sorry, in ordered manner. Three comma five. So if we divide it, so ideally it should be two comma one, and here in the min heap three comma five. Correct, guys? That's how they look like. That's how they should look like. Am I right or not? After inserting three, that's how they should look like. Everyone agree? That's how they should look like. Okay. Now let's move in. Let's take the seven here also. Let's take the seven here also. So after taking the seven here, you can see, guys, after taking the seven here, you can see this three will be moved out here again. So 3, 2, comma 1, and 5 and 7. Correct, guys? That's how they should look like. Then 3 will be, you can see again, max heap and min heap, different size. Take the peak element and 3 will be our answer. Then insert the 4 again. 1, 2, 3, comma 4, comma 5, comma 7. Then again do the, because it's the even scenario, so do this like this. So 3, comma 2, comma 1, and then 4, comma 5, comma 7. And for this should look like this. And 4 plus 3 will give us 3.5. Everyone agrees? That's how our min heap or max heap should look like. Correct? Correct, guys? We are trying to keep the size of min heap. Yes, min heap lesser. Yes, yes. In the odd scenario, Vishal, always will try to keep the min heap size lesser. Not in the even scenario. Even scenario, you can see every time when you are inserting in even, both are same. You can see this is the even scenario. Both are same. This is the odd scenario, odd. This is the even. Yes, now we'll see the insertion code, which you guys are waiting for. So see, guys, there are three steps. There are three steps which you will do every time. Which you will do every time. Whenever any new element will come, first you have to insert in max heap. First you will insert it here. Okay. After inserting it here, you will take the peak element from here and insert back to here. Insert that peak element here. Correct. So let's see. First you have inserted 1, and then you inserted 5. Correct. So in the max. Oh, okay. What happened? So see, guys, three steps. I'm telling you. Just see it here. Insert every element in max heap. Insert every element in max heap. Then take out the peak element from the max heap and insert it into min heap. Insert it into min heap. Insert it into min heap. And after that, once you do these two steps, step 1, step 2, once you do these two, just check the size. If size is equal, both side, min heap and max heap, if both sides are equal, or not equal, if the size is not equal, it means it's the odd scenario. If the size is not equal, it's the odd scenario. In those scenarios, we need to, you know that, take the peak element from min heap and insert into the max heap. So take the peak element into the, take the peak element from min heap and insert into max heap. See, this one you already got it, the last line, because we already know that whenever any odd scenario is coming, we always have to insert into the max heap. This one is fine. We have to little bit talk about these two steps. So guys, every time what I'm doing, every time whenever a new element is coming, I'm first inserting it into the max heap, because we need to maintain the order as well. That's why first we are inserting everything into the max heap. Then whatever the top element is here, whatever the top element is here, I am pushing it to the min heap, pushing it to the min heap. Then I am checking, is the size is same? Then do not do anything. You can see in this scenario, you can see 2, 1, 3, 5. This was there. This was the even scenario, right? Yeah, just see it here. This one, 2, 1, 5. This till now it was odd. Once we inserted 3, once we inserted 3, so first we'll insert into the max h. So 3 will be coming here. Just guys see from here. In the max, just see this example. In the max heap, we have 2, 1. In the min, we have 5. Now we are going to insert 3. So first, what is the first step? We are first going to insert that element directly into the max heap. So it will look like this, 3, 2, 1. Then take the peak element from here and insert back into min element. So 2, 1 and 3, 5. Now you can see size is equal. No need to do anything. No need to do anything. But after this scenario, if we are inserting 7, if we are inserting 7, so now again same step. First insert into the max heap. So 7, 2, 1, and here 3, 5. Again, take this element from here to the here. 2, 1, and 3, 5, 7. You can see guys, size is different here. Size is different. Whenever size is different, we need to take the peak element from here and insert back into this one. So 3, 2, 1, and 5, 7. And that's what you can see. After inserting 7, it looks like this. 3, 2, 1, 5, 7. That's why you can see 2, 1, 3, 5. So that's what guys, every time these steps we are following, these two steps are same. Insert and this one. And let me show you in the code as well now. The add element, not default. Every time we are adding the max heap element into the, every time new element is coming, we are adding to the max heap. Then we are adding the same peak element into the min heap, removing it from the max heap. If the size is different, if the max heap size and min heap size is different, we are taking the peak element from the min heap and adding it to the max heap. You have to do this continuously and you will get the array like this only. Every time we are, because see, max heap we have to take always one greater. That's why we are adding everything into the max heap. And once we are adding into the max heap, now we need to think about whatever the peak element is here, we need to move it to the min heap, and then we need to check the size. That if the size is equal, then let's go for. If the size is equal, then do not do anything. It means it's an even scenario. Everything is at the correct place. But if the size is not equal, take out the one element which we have inserted into the min, which we have recently inserted into the min, take it out from there and keep it here. That's what we are going to do, guys. Not difficult code. You can see the code here. Anyone has any queries? Just these two lines you can see, max heap, min heap. And you can see, yeah, before that, you can see for stream median, we have also created the class this time, not created the function, because we need to have two comparator here, right? Min and max comparator, because we need two min and max heap. That's why we are using min and max heap. You can see, guys, heap class is still here. We're not touching any method of heap class. Heap class is still there, but we have created separate class for stream median because we have to create like different these calls. That's why we have created a class here. And in this class, we have first our constructor, which will create two heaps, min and max heap. Same logic, we can do the same in the function as well. And then we have add number method and find median. Find median already shown you. Find median I've already shown you. And this is the add number, where we are first adding everything to the max heap, then taking it out from the min heap. And then we are checking if both are same. If both are same, do not do anything. If both are not same, take out the element from the min heap, because definitely we are adding into the min heap extra element, right? Max heap, see, everything we are adding in max heap, then moving it to the min heap. Then we are comparing the size between them. Understood, guys? Yes. I think after that, there are three more interesting questions. I think we have to take in the next class. Task scheduler and task scheduler is an interesting one. Rearrange string is easy one, and I think these are the problems which we have in the. I think again the median is there. You can see you have an array frame of length x. You have to slide that frame on the array and find the median in each frame. So earlier we have only two elements. Here we are going to have a frame of the three elements. So just think about this thing, guys, also. Because we have already done one medium question. So this question might help you here. What's the next one? Given a matrix of n cross n, sorted row wise, column wise, you have to find the kth smallest element in the matrix. Ah, we have done the similar question, right? We have to sort it. Yes, at that time we were sorted out. But here they are saying you have to find out the kth smallest element in those 2D matrix array, which are sorted already. So I think we can combine it and then do it. Just think about this one as well. And I think we have two more questions, job scheduler rearrange. I think I can ask Ansul give us the next class to continue these discussions. What do you say, guys? To continue solving these problems. I think there are four problems, and then there might be some doubt you guys will have. So I will definitely say to Ansul to give us next class to solve these heap problems. Yeah, let me show you the code in meanwhile to Joseph. These were the two very important functions, Joseph. Add number and find median. With the help of min heap or priority queue, these all questions become very easy. And this is the real use case actually of the min heap or max heap in the real time. The next question, job scheduler. That's the OS does. OS also uses that. That's what these are hard questions also. But you can see with the help of if you know if you have a Java, if you know Java, you do not need to implement this class every time. Automatically, you can take the priority queue and solve this question easily. Line number 113. Line number 113. Yeah. So in this line, what we are doing, we are taking the peak element from the max heap and inserting into the min heap. So this is we are doing every time. Joseph, we are doing every time. So first element which is coming, starting inserting from the max heap, whatever the peak element in the max heap, put it into the min heap, then compare it. Then compare it. If both max heap or min heap look same, do not do anything. If max heap or min heap looks little bit different in size, take the element from the min heap and put it into the max heap for the odd scenario. So line number 113 is just adding element in the min heap and taking the peak element from the max heap. Then we are deleting that max heap element in the line number 114. Yes, first we add every element in the max heap, then we take the peak max element from there and put it back into the min heap. Yeah. Okay. So I hope this question also was interesting. I hope you guys have find it interesting, and I know you guys have curiosity to see the insertion code as well. And the insertion code was also very easy. It was not difficult. I know you guys were thinking like a lot of things here about the insertion code, but so how you guys are feeling after solving two hard questions, two medium questions, and you have also, I am sure you guys have also understood the logic. Yeah, please try to solve all the questions. Just not, if you're not able to solve it, just think about it. Everywhere we are going to use these things only: min, max, heap. In all the remaining questions, min, max, heap. And this code is already available in the GitHub. So every time you need to just do the class, put the class there. In every question on the top, put this class heap, and then start your function, start your class, start your logic there. Yeah. So we just need to think about the min and max and just practice it. This was, and these are like We would achieve nirvana. These days Nirvana companies are firing also. From these Nirvana places, people are falling it into the ground. So yeah, very bad thing is happening. Yeah, a lot of companies are firing these days. Yes, I have like one list where a lot of companies are firing. Yeah, that's the old news. Meta fires 10,000s. More than 10,000, I think they fire, right? 11. Amazon is going to fire 10,000s. That was the latest news, right? Yeah. Twitter has already done it proudly. They are feeling proudly as well. In my company right now, they are not firing anyone, but I have seen the news. I think in the month of July or near to that, they have fired some people from the San Jose. 85 people they have fired it from there, but not right now. I think it has happened 3 to 4 months earlier in the San Jose, yes. And it's happening mostly with the US citizens, US employees I'm seeing, not with the India, because India employees already they have cheap, right? We are the cheaper rates people, cheap people we can say. So that's why we are not getting fired. See, why are they are? That's true also, Arad. Hard to hear, but that's true also. That's what they sing. That's what they think about us. Every time, whenever anyone is hiring you from the outer locations to India, they always think in that way only. Always. There is no other intentions. I'm telling you guys. There is no other intention. And I have worked with the Israeli people. They are really very smart people as well. Compared to us, I would say that they are very smart people. Israelis, Jews, right? So those people are very intelligent. I have worked with them, I think 8 to 9 months, and I learned a lot of them, lot of things from there. How the minute things they see it there. I was very excited working with them. So why they fire actually? Yeah. So see, they are firing because their business is not growing. Investor is not getting money back. Always the reason is, for the Meta they were saying all of their products are now at the stable stage. Like WhatsApp, Instagram is still booming, but I think WhatsApp and all other they all other they are just generating a stable revenue. They are just generating a stable revenue, but the investor why? And they all get the money from investors. So invest when investor is not seeing any profit, so why investor will invest in your company? So that's what I was hearing, that the investors from the Meta, they are saying that we are not seeing any profits, why we should invest money in your organization. So that's why they have started firing. Now what they need to do, they have to reduce their workforce. That's why they are firing it. I think, and one more reason was I was reading somewhere the Meta has jumped into the metaverse, which was very nice. Metaverse is very nice. It's going to be future, but people were saying it's not right time, right? Like it's not the time for like it's not the correct time when people are going to jump into directly into the metaverse. They have not created the market fully for that. Like I'm not sure any one of us is using right now metaverse, and we are the young generation, right? I'm not sure, like might be some people are using it, but I'm not sure many of them are using in metaverse right now. But that's it, that is definitely going to be the future. But that's what they entered, they invested a lot of money in metaverse, but they're not getting revenue back from anywhere. So that was also one drawback. So that these are some of the reasons I'm seeing Meta has fired these many people, and Amazon is also firing some people from sales or Alexa content management, or not engineering, but from the HR and these positions they are firing it. Or for Twitter, so everyone I think know about the Twitter, what's happening there. Elon Musk has come with some other next level ideas. So wherever he's seeing problems, he's just saying people to get out, do not come directly to office. That's happened. That's the true actually about the private companies. But see, these are some of the companies which will definitely jump on, like see, in the Meta, I only see that engineering positions has been fired, but if you will choose the nice companies like which have good finance with good futures, I think Amazon Meta has also good futures. But yeah, that's the reason for Meta. I told you that where they're investing right now, they're not getting revenue back, the, whatever they expect. So that's why this is happening. But see, IBM is not firing. Indian companies like Infosys is not firing. TCS is not firing. They might be pause on the hire, pause a freeze or put a freeze on the hiring part, but they're not firing anyone. The service-based company, they're not firing anyone. So see, there are like JP Morgan is there. They're not firing anyone. They're hiring and is still they're hiring. You can see they're hiring. JP Morgan is hiring. PayPal is also not firing anyone. They're like my recently I have the hand like all hand with the CEO. They're also not firing anyone. Accenture is firing. You are saying, Joseph. I'm not sure about the Accenture. What's the reason there? But yeah, they should not fire it actually. They should retain their employees. Not sure why they're firing it. I think on the India they should not fire it. We are already not the that much higher cost. So not sure what Accenture is firing is India or in the US, Joseph. Or you just read the news Accenture is firing. Might be they are firing in US. I will read it. Might be in India. Okay, okay. Is it the engineering team they or the like the same HR or content management or marketing team, something like that? But yeah, like definitely the layoff is not good. And you know, guys, after last 1 and 2 years, they have also done a lot of hiring, extra hiring. They have done it. That's also one reason some of the organizations are right now laying off because they have done massive hiring. Everyone was getting like in the LinkedIn. I was seeing every day, like not every day, in 1 or 2 hours, I was seeing 4 and 5 people are saying that I got offer from these 5 organization. I'm choosing this one. I'm choosing this one. So you can see that massive hiring was happening in the COVID period. So I think where will these all people will go who has been hired? So definitely they all also have the vision that this is going to happen. But let's see. I'm hoping that you guys also got very good. So see, you guys are still practicing and start applying for the job. It's not going to be like IT companies are that much bad. I'm not giving you the fear here, but I'm telling you, still the real talent exists. So a lot of companies are not firing. I've not seen any of my friends are fired in IBM or in Infosys or any startup company is fired in India. Like some of my friends are working in, in the New Rocket or some other places. You know, they have not fired anyone. So do not fear or do not fear like that. It's happening. It will again like they will again recover it. Okay. So yeah, I think we have spent 7 more minutes on these side topics. So I will talk to Ansul, and we'll on Friday we'll talk about the same remaining problems here. Okay, guys. But before that, I want you guys to practice it. Okay. Anyone has any fear or anything like that? We have talked about all these things, guys. Nobody is responding. What happened? We need Tata. We're talking about Tata Motors car or Tata stock. So TCS is, I'm not sure TCS is hiring or not. Oh, that's fine. That's fine. Okay, guys, that's all. Let's go for sleep. Let's do not think about these things. Continuously apply. I'm telling you, JP Morgan is hiring these days. So connect with their HRs and let's see if you guys got lucky. JP Morgan is a bank and it's an international bank. So, and they are doing good business. So definitely they are not going to fire anyone. So let's see if you guys uh, can connect with any of the HR of the JP Morgan and put your resume there. Okay, guys. So let's end our class with this last point, and then we'll meet on Friday. Okay, guys. So good night. Bye bye. That's totally right. No, no, no. People are having fear that, like some people are having fear that they should be joining IT organization, they should be practicing these questions or not. That type of fear people are having because they are seeing that people are firing, people are laying off. Why should we go towards that? But that's what I'm saying. Do not have this fear. Still at good future. Okay. So yeah, you guys are still in the like in starting phase. So whatever first job you got, take it. Yeah, very good night, guys. It was very nice talking to you at the last, and also solving this question. I also got very interesting. So yeah, let's close it and let's meet on Friday. Bye bye.